Hello everyone, this is Said Piri and welcome to Tutorial Zone. So today we're going to start our math series and we're going to start with a topic that learners most of the time find challenging, but in actual sense it's not challenging. And this topic is earth geometry. So in this topic we're going to talk about a couple of stuff, and after that we're going to look at how we can be calculating questions that examiners can set under this topic of earth geometry. So we're going to look at the definition, we're going to look at great and small circles, we're going to look at location of places, we're going to look at difference in latitudes and longitudes, then we're going to look at distance along longitudes and latitudes, then we're going to talk about time and speed calculations. The reason why this topic is important is because you can actually use it to calculate time differences, to calculate the speed, to calculate differences in latitudes and longitudes, as well as in the location of points on the Earth's surface. So we can start with the definition. So Earth geometry is simply defined as a branch of mathematics, that deals with one, location of points, two, calculation of time differences and speed. Number three, calculation of distances along the Earth's surface. So before we go into all these that we have mentioned here, one of the most important things that we have to look at are the great circles as well as small circles. Why am I saying so? This is actually one of the basic things that you need to understand for earth geometry to become easy for you. So what are great circles? So great circles can be defined as the imaginary lines on the Earth's surface, which are longitudes and latitudes that have got the center on the center of the Earth. What do I mean by that? For example, we are going to take longitude A. If you look at longitude A, its center is actually on the center of the Earth's surface. So those are what great circles are. In other words, great circles are those imaginary lines which are longitudes and latitudes that divide the Earth into two equal hemispheres or two equal halves. The other great circle is the equator, and we should take note that the equator is the only latitude that is a great circle. The equator is the only latitude that is a great circle. You can actually see the equator here has got the center on the Earth's at the center of the Earth's surface. So with that said, the other thing that we need to put into consideration is that all great circles, which are all longitudes, and the equator have got the radius of 6,370 kilometers or 37 nautical miles. We're going to talk more about nautical miles when we come to speed calculations as well as distance calculations. So this means that this radius from the center to the end of this longitude is the same as 6,370 kilometers as well as 37 nautical miles. In addition, this is also the same for the equator. The radius will be that of the Earth's radius, which are shown here. Then we can also take note that all the remaining latitudes are not going to have the radius of the Earth there. They're not going to have the radius of the Earth. And the reason is that these remaining latitudes are small circles. And what is a small circle? A small circle is an imaginary line which is a latitude that has got its center not located at the center of the Earth. If we look at latitude B, here, its center is not located at the center of the Earth. It is actually located here near the South Pole. So those are what small circles are. And except the equator, all latitudes are small circles. Due to that reason, their radius will be given by r is equal to r cos x degrees. R is equal to r cos x degrees, where r is the radius of the Earth, which is 6,370 kilometers, or 37 nautical miles. 37 nautical miles. And x degrees is actually degrees for a specific latitude. For example, if latitude B is 60 degrees south, this means that x degrees will be 60 degrees south. And r is actually the radius of this small circle that we are going to find. So with that said, the things that we need to take into consideration here are two things. One is that all longitudes as well as the equator are great circles and have the radius of the Earth, which is 6,370 kilometers, as well as 37 nautical miles. The second thing that we need to look at is that all latitudes except the equator are small circles and have the radius r is equal to r cos x degrees. Then something that is worth mentioning as well is the formula for circumference. Circumference is equal to 2 pi r. Circumference is equal to 2 pi r, where r can be the radius of the Earth or can be the radius of a small circle, depending with what you are finding in a particular question. So with that said, we have laid a base of Earth geometry. What we are going to talk about now, before we talk about location of places, we're going to talk about the Greenwich meridian. Remember, the equator has got a degree of 0. Amongst the longitudes, the Greenwich meridian is the one that has got a degree of 0. So these two, the Greenwich meridian and the equator, are actually points on the Earth's surface where they have been used to calculate the distance from a particular, the distance from the Greenwich meridian and the equator to a particular point or to a specific point. So these will be talked much more in one of the examples that we're going to give later on as we proceed in our lessons. So about the location of places, the concept here, which will be concept 1 of our lesson, which will be concept 1.0 of our lesson, is that when you are locating places on the Earth's surface, you start by giving the latitude value as well as the longitude value as the ending value in a form of a coordinate like what we have seen there. So The easy and funny mnemonic that we can use to remember this is that you just say la, lo. La to mean latitude and lo to mean longitude. So these latitudes are actually imaginary lines that run from east to west, east to west. However, these are actually denoted using north or south because they will be on the north as well as on the south of the equator. So whenever you give out a value for a latitude, it should end with either the north or south, depending on where it is located with respect to the equator. Then longitudes are going to they run from north to south, and they're going to be denoted or shown by east or west. Why is it so? Because they can either be on the west or on the east of the Greenwich meridian. So we'll see more on this when we start doing our questions. That said, we are done with the location of places, great circles, and we have given out the definition. So what we're going to look at now is how you can get the difference in latitudes and longitudes. So the guiding thing or the concept, which will be our concept 1.1 of our lesson, which will be our concept 1.1 of the lesson, is that when you're finding the difference in, we'll start with latitudes. You need to keep in mind two things. One is that you add points, or would say latitude values or degrees, latitude degrees that lie on opposite sides of the equator. That lie on opposite sides of the equator. Supposing we have point A here to the north and point B here on the south of the equator, you get the degrees. Let's say we have 65 degrees north and 75 degrees south. For you to find the difference in latitudes between A and B, you add these values because they are on opposite sides of the equator. So the thing that should help you remember is that when you have north-south combination or south-north combination, for you to get a difference in latitudes, you get to add the values of those particular latitudes you're talking about. The second thing that you need to remember is that you subtract the latitude degrees that lie on the same side of the equator. On the same side of the equator. So in other words, the combination of the latitudes that you have to subtract can either be both latitudes, or both points can either be to the north, which is north-north, or they can either be south-south. When you have such a combination of latitudes, you get to subtract when finding the difference in latitudes. For example, supposing B wasn't to the south of the equator. Let's say we have another latitude here just after the equator. Then you have point B here, which is 75 degrees north. Because our combination is north-north, or because they are both on the same side of the equator, when finding the difference in latitudes, you get to subtract in order to find the value which is the difference in latitudes. Similarly, when you're talking about longitudes, the two things that you need to remember when finding the difference in longitudes are that first, you add longitude degrees that lie on different sides of the Greenwich meridian. This time around, we're talking about the equator because longitudes can either be to the west or to the east of the Greenwich meridian. So if you have a combination of west east or east west, you get to add the values of those longitudes in order to find the difference in longitudes. The second thing that you need to remember is that you subtract longitude degrees or values that lie on the same side of the Greenwich meridian, GM, the Greenwich meridian. So you can actually see that it's actually the same even with latitudes. The only difference is that we're talking about the equator when we are dealing with latitudes, and we're talking about the Greenwich meridian when we're talking about longitudes. So I'll go through again. You subtract those values that lie on the same side of the Greenwich meridian or on the same side of the equator. Then you add those points that lie on opposite sides of the equator or on the Greenwich meridian if you're talking about. Okay, so now that we're done with the difference in latitudes and longitudes, I want to go to distance along longitudes and latitudes. So we'll start by first going back to what we had already said about great circles and small circles, because this is going to apply on when we are calculating the distance along longitudes and latitudes. The other thing that we're going to I'm going to emphasize on will be the difference in latitudes and longitudes, because we also need it when calculating the distance along longitudes and latitudes. So we'll start with the distance in longitudes. Distance in longitudes. So I'm going to put points on the Earth's surface, our module here, to help us in understanding what we're going to talk about. So I'll put A here, I'll put B there, I'll put C here, and I'll put D there. Supposing someone says we calculate the distance in longitude along AB, we calculate the distance here between A and B, between point A and point B. What you need to ask yourself first is that, are those points lying on the same latitude or on the same longitude? So if you look at A and B, they are on the same latitude. They are on the same latitude. I'll put this as latitude C for reference. They are on the same latitude, which is latitude C. So since those points are on the same latitude, this means that we are calculating the distance along latitude C. We are calculating the distance along latitude C. Then if you look at A and C, sorry, this was supposed to be here. If you look at A and C, they are actually on the same longitude. So because they are on the same longitude, this means that we are calculating the distance along the longitude between point A and point C. So that's the first thing you need to ask yourself. If points are lying on the same latitude, then they ask you to calculate the distance between those 2 points. Definitely you are calculating the distance along that latitude. If you are on the same longitude, definitely you are calculating the distance along that longitude. So since we are starting with the distance along the longitude, so let's say we're calculating the distance between A and C. So you say distance AC, some say arc AC. I will explain about this arc AC as we are going to do our last example of this eighth geometry series. But you can actually say arc AC, or you can say distance AC is going to be theta over 360 degrees multiplied by 2 pi r. Now remember, before I started talking about this, I said we're going to go back to the great circle and small circle, which was our second thing that we talked about in this video. So remember, when I was talking about the great and small circles, I said all longitudes are great circles. All longitudes are great circles, and I said all great circles have got the radius of r is equal to 6,370 kilometers, or 37 nautical miles. So this means that all longitudes as well as the equator have this radius. So it depends with the one that the examiner wants you to use. They will mention, if they say kilometers, you use that. If they say nautical miles, you're going to use that. So that's what will be our value for r there. This formula is only used when you're calculating distance in longitudes. Now, what is theta? What is theta? Before I explain what theta is, let's take a look to where point A and point C are. You will realize that point A and point C are on the same longitude. That's the reason why we are calculating the distance in longitude, or the distance between A and C, because they are on the same longitude. But you will realize that point A and point C are on different latitudes. Point A is on latitude C, point C is on latitude B. So theta is actually the difference in latitudes. Which latitudes are we talking about? The difference in those in the latitudes where the particular points lie. So this will be the difference in latitude C and latitude B, where point A and point C lie. So when you're calculating the distance in longitudes, theta will be the difference in latitudes. And you keep in mind the rules or the concepts that we have talked about on the difference in latitudes and longitudes. We said you add those latitudes that lie on different sides of the equator, and you subtract those latitudes that lie on the same side of the equator. So this is actually concept 1.2, since the previous one was 1.1. So that concludes on how you calculate the distance in longitudes. We'll explain more when we start looking at particular questions. Now let's see how we can calculate the distance in latitudes. Now remember, I said for you to know that you're calculating the distance in latitudes, you will see that those two particular points are lying on the same latitude. The only difference is that they will lie on different longitudes, but they will be on the same latitude. Let's look at how point A and B is. Point A and B are on the same latitude, which is latitude C. So if you're calculating the distance between A and B, definitely you're calculating the distance along latitude C. So distance AB, or arc AB, is equal to theta over 360 degrees multiplied by 2 pi r cos x degrees. Remember, when we're talking about small circles, I said small circles do not have the radius of 3437 nautical miles or 6,370 kilometers, because these small circles do not have their center on the center at the center of the earth. They don't have their center at the center of the earth. So this radius here is not actually that which is the radius of the earth, simply the radius r. And we have said r is given by r cos x degrees. So this is what we have here. We're actually using this value because these latitudes are not actually great circles, I wish in one of my videos I would explain on how this r cos x comes about, but for now it's not that important. So let's discuss on what theta is and what cos x is, because we know what r is, which is this value there or that value there, and we know what pi is, it's a constant. But what is cos x degrees and what is theta? That's what is important. If you can understand these two, definitely you are come and dry with this formula. Theta here is actually the difference in longitude. When I was talking about the distance in longitude, I said theta is a difference in latitude. Why? Because point A and point C lie on different latitudes. They lie on different latitudes. But if you look at point A and B, when you're calculating the distance in latitude, you realize that point A lie on a different longitude as point B. So because of that, theta is a difference in longitudes. And we have talked about how you calculate the difference in longitude. We said you add those points that lie on different sides of the Greenwich meridian, and you subtract those points that lie on the same side of the Greenwich meridian. So theta, when you're calculating the distance in latitude, is the difference in longitude. I won't really talk about cos x. I'll leave cos x. I'll just say x degrees. X degrees is that latitude where AB in this example lie, where AB lies. So if you look at A and B, they lie on latitude C degrees. So supposing C degrees is 55 degrees, X degrees is going to be 55 degrees. So you get to find cos 55 there. You put it when you're calculating your distance in latitudes. Okay, so now that we have talked about the distance along longitudes and distance along latitudes, which I'll explain much more with a practical example in the next video, we're now going to talk about concept 1.3, which is time calculation. Now, what you need to know about time is that the Earth rotates around this axis for 24 hours. Rotates around this axis for 24 hours to make one day. Now, a complete rotation is 360 degrees. Now 24 divided by 360 degrees will give us 15 degrees. So this means that 15 degrees, when the Earth makes a rotation of 15 degrees, it will rotate for 1 hour. So 1 hour, the Earth will rotate for 15 degrees. This also means that for every 4 minutes, the Earth will rotate 1 degree along its axis. So what you should know is that the difference in time between 2 points will be given by the difference in degrees, or would say, let's use the difference in longitudes. So do not ever make a mistake of using latitudes, because time is not calculated in longitude. In latitudes, it's calculated in longitudes. So difference in longitudes, which we have already mentioned here, over 15 degrees. This will be in hours. This is going to give us in hours. So let me just write that formula somewhere better so that we should be able to see. So we are saying difference in time is equal to difference in longitudes over 15 degrees hours. So this, in short, this formula is actually just helping us to change from degrees to hours. So we'll first start when calculating time. We'll first start by getting the difference in longitudes. Getting the difference in longitudes between these two particular points. Suppose we are finding time differences between A and B. We'll first start by getting the difference in longitudes between A and B, then use this formula to convert to hours, and then the final thing which I want you to understand the most is that, one, add the time difference for points that are to the east of Greenwich meridian. By the way, the Greenwich meridian, that's a reference point from where time is calculated. So that's why you end up having the Greenwich Mean Time, GMT. So let me just go through over that. I was saying, after finding the difference in longitudes, and we have used this formula to convert it to hours, now you add the time difference for that point, for the points that are to the east of the Greenwich meridian. Supposing that we are finding time at B, and B is to the east, and we have been given the time at A to be 9 hours. So if you find that your difference in time is 2 hours, you just add that to the time that you have been given, Why are we adding? We are adding because B is to the east of the Greenwich meridian. The second thing that I would like to talk about is that you subtract the time difference of those points that lie to the west of the Greenwich meridian. Subtract the time difference for points that lie to the west of Greenwich meridian. So the other thing that you need to put in mind is that when you're calculating these time differences, you should also try to look at the dates that has been given if the question asks you for the date. So if you notice that the time difference that you have gotten is leading you to somewhere after 24 hours, definitely the date will change. So you need to put that into consideration as well. So with that said, that's how you calculate the time. Now let's talk about the last part, which will be concept 1.4, which will with now that we're done with time calculations, let's look at concept 1.4, which will be our last concept of this video, which is speed calculation. Now we know that speed is given by total distance over time taken. So the time is either they can give you total distance to find, and they give you a time taken to find the speed, which is a rare case. Most of the time you get to calculate the distance on your own. And how do you calculate the distance? We have already mentioned how you calculate the distance in concept 1.2. In concept 1.2, we have already mentioned on how you calculate the distance along longitudes as well as latitudes. So if the total distance has not been given, you calculate the distance as mentioned in that concept using the formula. If it's longitudes, arc AC or distance BC is equal to theta over 360 multiplied by 2 pi r. If it's in latitudes, distance AC is equal to theta over 360 multiplied by 2 pi r cos x degrees. That's how you calculate the total distance. The time taken, most of the time is usually given, unless otherwise they give you the speed to calculate the time taken. So, but if they give you the time taken, then they want you to calculate the speed, you need to calculate the distance on your own using this concept that we talked about there. Now, most of the time, the speed that you're usually going to calculate is usually going to be in nautical miles per hour. Nautical miles per hour. Why is it so? It's so because most planes and ships use this. Instead of kilometers per hour, they get to use nautical miles per hour. Now, what I need you to understand is that 1 nautical mile per hour is equal to 1 knot. Is equal to 1 knot. So if my speed is 20 nautical miles per hour after calculating, if it's 20 nautical miles per hour after calculating, this means that I've got 20 knots. I've got 20 knots. So there's nothing much to talk about speed. With that said, in this video we have talked about the definition of earth geometry. I've talked about great and small circles. I've talked about the location of places, which I've said you start with the latitude, you end with the longitude. And I've actually given you the difference in latitudes and longitudes, which I've said you add those 2 points that are on different sides of the equator or the Greenwich meridian, and you subtract those 2 points that are on the same side of the equator or the Greenwich meridian. And I've actually given you how to calculate the distance along longitudes and latitudes. The most important thing that I want you to remember here is that theta, when you're calculating the distance in longitudes, theta is a difference in latitudes, and when you're calculating the distance in latitudes, theta is a difference in longitudes. The other thing that I want you to remember is the value for r. In longitudes, you use the radius of the Earth, which is 6,370 kilometers or 3437 nautical miles. In latitudes, you use r is equal to r cos x degrees, where x degrees is that particular latitude where those 2 points that are calculating the distance for lie. Then with time calculations, the most important thing that I want you to remember is that for the formula that I gave you, the difference in time is equal to difference in longitudes over 15 degrees. Your answer is going to be in hours. That formula is used to change from degrees to hours. The other thing that I want you to remember is that you add the time difference to those points that lie to the east of the Greenwich meridian, then you subtract the time difference for those points that lie on the west of the Greenwich meridian. With that said, this wraps up our first video of earth geometry. Don't forget to share, don't forget to like, don't forget to subscribe. Turn on that notification button in order to receive more videos that are coming. I've got a lot that has been put for you. I've got a lot that we have prepared for you, and I'm sure you are going to really love it. I'm the presenter.